All right, dudes, we're going to solve some modulus equations. So we have g of x equals 4 minus 3 over 2x and h of x equals 5. So I've done a little initial sketch here. On the same axis, draw graphs of y equals g of x and y equals h of x. So this would be my h of x and this is my g of x. And I put it in the calculator as well. And it's always really, really important to pop it into a calculator just so you can get a feel for what's going on. Look at the solutions, and then that way, after you've done the question, you've got to show your algebra most of the time in the A level, but you can just come back and see whether you were right. So I already know one of the answers I'm looking for is minus 2/3, and I know the other answer that I'm looking for is y equals 5, x equals 6. So if I don't get those answers, I know I need to change something. So I have two parts to this g of x. In this first instance, the argument is positive and therefore the modulus isn't doing anything to my function. So in essence, I have y equals 4 minus 3 over 2x. Now on this second branch, the argument is negative. What that means is my modulus function is acting to change that negative sign into a positive, or I could express that in the following way. I could say y equals minus this argument 4 minus 3 over 2x. Okay, so essentially I have two different functions that are completely distinct from this vertex here. Now they both intersect with h of x, which is just 5. So these 2 points are going to come from this first equation equals 5, 3 over 2x equals 5. That's going to be this point here. And this second point here will be minus 4 minus 3 over 2x equals 5. So let's find these 2 points. So I've got 4 equals 5 plus 3 over 2x. I've got 3 over 2x equals, I'm going to take 5 away from both sides, so that's minus 1. So then 3x equals minus 2, x equals minus 2/3. And I already know that's what I wanted, right? And let's look over here. So let's distribute this negative. So that's minus 4 plus 3 over 2x equals 5. We're going to add 4 to both sides. So I have 3 over 2x equals 9. I have 3x equals 18, and then I have x equals 6 minus 3 over 2. And I know these are what I was looking for because I checked on my calculator. So if these values were different, then I would be having a think. Right, let's just do this last one here. So firstly, let's split this into two functions. Let's say y equals modulus x over 6 minus 1. And let's think about y equals 3. I'm going to plot both of them on my calculator and see where they intersect and kind of make a little sketch. So x over 6 minus 1. Let's go expressions. Y equals, just delete this, x divided by 6 minus 1. And then I have y equals 3 here. Okay, plot. And I can see I'm expecting two solutions. One which will be at x is minus 12, y equals 3, and in quadrant 1, I have this one, x equals 24, y equals 3. So let me just zoom out a little bit so we get a better sense of that. So it looks like layout. Okay, so let's just do a little sketch, a Reno, so we know what we're looking for. So I have my modulus function, the vertex is here, and then I have this second function, y equals 3, so that's y equals 3. And we can start thinking about how we can find these 2 points of intersection. Okay, so in this side, so this is the point, this will be the point 6. This will be the point 6 here, if I can actually draw. There you go. X equals 6. When x is bigger than 6, this is a positive number. My argument is positive. That means my modulus function isn't really doing anything at all because the argument to the modulus is already positive. So my modulus doesn't act at all. It just returns that positive. So I can think of this as y is x over 6 minus 1. On the other side, however, the argument is negative. So from that vertex going left, this argument will be negative. That means that my modulus is acting to reverse the sign, or I can say x over 6 minus 1. So I can express this as two different distinct functions. This line is y equals 3, and it just remains y equals 3. So it's y equals 3 over here as well. So I can look at these 2 points of intersection now. In this first instance, I have minus 1 x over 6 minus 1 equals 3. And in the second instance, I have x over 6 minus 1 equals 3. So let's solve both of these, and then we can check. So x over 6 equals 4, x equals 24, and then I have minus x over, I could have just, it's fine, we started, we'll finish. Minus x over 6 plus 1 equals 3, so then I have minus x over, let's add x over 6 to both sides. So we'll go 1 equals 3 plus x over 6, x over 6 equals negative 2, x equals negative 12. Yep, negative 12 and 24, and then we can have a look. 24, b negative 12. Yeah, good, cool. So one of those questions where you know you're right, which is lovely. So I hope that helps.